Now the seventh question we are going to solve, my dear students. A light source of wavelength 520 nanometer. It emits 1.04 into 10 power 15 number of photons per second. While the second source of wavelength 460 nanometer emits 1.38 into 10 power 15 photons per second. Then the ratio of the power of the second source to the power of the first source is. What is the option we have to find out? So, what we have to understand first of all, when we switch on any source of light, it emits photons. In 1 second, how many number of photons are emitted by the source? The number of photons emitted per second. So, I will write this is number of photons emitted per second by the source. So, number of photons emitted per second, that will be equal to what? Power divided by the energy. Power. So, power divided by energy. The number of photons emitted per second can be taken to be N. The power can be taken as capital P and energy can be taken as what? Capital E. So, this equation implies that power is equal to N into E. So, this is the basic equation we are going to use to solve this problem. So, power is equal to what? Energy divided by time. Is it not? Power is equal to energy divided by time. So, this number of photons emitted per second is the it is the frequency of the emission of photons. So, power must be equal to N times E. Okay, students? Now, what are all the given quantities here? You see, wavelength lambda 1 is equal to how much it is given? 520 nanometer. So, this is equal to what? 520, okay, into 10 to the power of minus 9 meter. Okay. Then what is lambda 2 given, you tell me? Lambda 2 is how much? 460. Okay. So, this is 460 nanometer means 460 into 10 to the power of minus 9 meter. Now, the energy incident, okay, corresponding to the first wavelength E1, this is equal to what? Hc by lambda 1. And the energy corresponding to the wavelength lambda 2 is given by E2. So, this is equal to what? Hc divided by lambda 2. H means what? Planck's constant. C means what? Velocity of light, which is also a constant. Therefore, I can write E1 is proportional to 1 by lambda 1 and E2 is proportional to 1 by lambda 2. So, if you take the ratio of E1 by E2, see here, I will take the ratio E1 divided by E2. You see here, E1 is proportional to 1 by lambda 1 and E2 is proportional to 1 by lambda 2. Therefore, what must be E1 divided by E2 must be equal to lambda 2 divided by lambda 1. So, this is another intermediate step which is of very important. Have you understood up to this, my dear students? Okay. Now, when lambda 1 is 520 nanometer, how many number of photons are emitted per second is taken as N1. So, I will take a number of photons. N1 is equal to how much? 1.04 into 10 to the power of 15 per second. Okay. Similarly, when lambda 2 is equal to 460 nanometer, what is the number of photons emitted is N2. So, I will take, so this is N2 is equal to 1.38 multiplied by 10 power 15. Okay. So, now I will write this equation. See here, P is equal to N times E. So, the power P1 is equal to N1 into E1. Then the power P2 is equal to what? N2 times E2. Now, what is asked here? The ratio of the power of the second source, that is P2, to that of the power of the first source, that is P1. So, which ratio is asked? it is P2 divided by P1. So I am going to divide this second equation by the first equation. So this P2, okay, P2 divided by P1 is equal to what? N2 into E2 divided by N1 into E1. So this is equal to what? N2. So this is N2 divided by N1 into, already we have derived E1 by E2 is equal to lambda 2 divided by lambda 1. Now we want the reciprocal of that, E2 by E1, E2 by E1, that is equal to what? Lambda 1 by lambda 2. So this is lambda 1 divided by lambda 2. So now I am going to substitute. So this is now equal to what? What is the value of N2? N2 you see here 1.38. So this is equal to 1.38 multiplied by 10 power 15. Okay, 10 power 15 into what is lambda 1 we have to substitute. So lambda 1 is what? 520 nanometer. So this is equal to 520 into 10 to the power of minus 9 nanometer divided by what is N1 has to be substituted in the denominator. So this is what? 1.04 into 10 to the power of 15 into 460 nanometer. So this is equal to what? 460 into 10 to the power of minus 9. So we can cancel the powers of 15. Okay, 10 power 15 and 10 power 15. Similarly, we can cancel the powers of 10 power minus 9, including this 0 also can be cancelled. Therefore, P2, okay, divided by P1. P2 divided by P1 is equal to what? We are going to multiply using the calculator, that's all. Keep the calculator ready so that you can multiply and verify it. Okay. So, I will take the calculator and I will multiply. So, this is now equal to 1.38 into 52. So this is 1.38 into 52 divided by 1.04. So this is 1.04 into 46. So into 46. This ratio only we are going to find out. Okay, if you find this ratio means what will be coming, I will check now with the calculator. So first of all 1.38. So 1.38 multiplied by 52. Okay students, so this is 52 and that is equal to 71.76. So this is 71.76 is coming divided by, similarly you calculate the denominator. Now you see here 1.04, okay, multiplied by 46 and that is now equal to 47.84. So this is 47.84. So this is 71.76. 71.76. Okay, 76. We have to divide it by 47.84. So this is 47.84. So this is equal to 1.5. So this is equal to 1.5. So such numbers, if any shortcut is there means you can divide it by 2 or 4 or any divisible number. Okay, and you have to find out. See, the mathematical part only by practice you can understand. My dear students, have you all understood the problem? So the power in general is energy divided by time taken. So energy divided by time taken is also equal to energy into frequency. Here the frequency is nothing but the number of photons emitted per second. So this is the basic idea. Okay students, have you understood? So what is the ratio of the power we have got? P2 by P1 is equal to 1.5. So which option is correct here is option C. Therefore option, okay, option C is the correct answer. Okay. Shall we go to the next problem? Fine.